Welcome students. So welcome to the unit second of 10 plus 2 current electricity, and today's topic is electric power, electric energy, Joule's law of heating and heating effects of current. All these topics can be summed up as a one topic if you are smart enough. Now, what is electric power first of all? Now, electric power is the work done for bringing a current into a conductor if 1 volt potential difference is applied to it. So which means it simply can be calculated by the previous formulas as well. Now we all know what is potential difference. Potential difference is V is equal to work upon charge. We all know that is work upon charge. And you can also write it as work upon charge. Now, if you want to find out work, that is going to be potential into charge. Now, you all know what is charge is all about. The charge is always equal to, yes, current into time, or let's say I into T. So, which means work is always going to be equal to potential and multiplied by I into T. And you all know what is power. Power is work upon time. So which means you can bring that time period here. So which means W upon T is going to be equal to VI, and work upon time is going to be power, and that is the formula for power. It's very simple. So power is going to be equal to potential difference into current, and you can also modify that formula to some extent by applying Ohm's law. Now what is Ohm's law? You all know what is Ohm's law. That is V is equal to IR. So which means, so power can also be written as, now putting the value of V from here, so that is IR into I. So which means power is also can be written as I square R. So that formula is also for power. We can also modify that too. So if you want to have from Ohm's law, and what is the value of current is going to be? That is going to be V upon R, and you can modify that formula as P is equal to I square R, and now just put up the value of I, which is current, which is V upon R. So which means V square, yes, upon R square into R. So therefore power can be written as V square upon R as well. Now these are the three formulas for electric power. Now these formulas are very easy, and why we use three formulas? Because according to numerical, whatever the values given to us, if the value of potential difference and current is given to us, we can use that formula. If we are given current and resistance, then we can use that formula, and if the potential difference and resistance given to us, then we can use that formula. So that is how we can modify the electric power formulas. And if you want to have a statement of that, we can also have a statement from here. Now what are going to be the units? Now you all know what is power. The power is having SI unit of watt. So 1 watt is equal to 1 volt into 1 ampere. So if you want to have a statement from that, 1 watt is equal to 1 volt into 1 ampere. So it's very simple. So 1 watt is that power. So if 1 ampere of current flows through a conductor, and when potential difference is 1 volt applied across the conductor. So it's going to be very simple. If you want to have a definition or statement of the watt, so it's going to be very simple, but watt is not going to be the practical unit of power. You all know the practical units are going to be kilowatt. Now what is kilowatt? So that is 10 raised to power 3. Watt is known as 1 kilowatt. And megawatt. Now what is megawatt? Now what is megawatt? That is 10 raised to power 6 watt. Now these are the practical units we use for electric power. Now the next topic is electric energy, and it's going to be very similar kind of topic. So I'm just erasing that. If you want to have the next topic, that is known as electric energy. Now how we can solve electric energy? It's going to be very simple. Now electric energy. what is electric energy? Again, we are going through the same thing. So we all know what is power, that is V into I. Now, power is going to be work upon time. So V into I. Now, that work is going to be V into I into T. Now, that work is stored as energy. So, which means, so we can use E here. So, that is V I into T. So that is going to be the formula for electric energy, and you can also modify that. That is E is equal to V into I is power. We all know power is going to be VI. So P into T. So that formula can also be used as electric energy. We all know what are the SI units of any energy, that is going to be joule. So but the practical units, now practical units are, so this is going to be, if you want to have 1 joule, so that it can also be written as 1 watt into 1 second. So we can modify 1 joule into 1 watt and 1 second in energy segment as well. And what are the practical units? Now practical units of energy, electrical energy, are kilowatt hour. So which we are using in our electricity bills as a units. So kilowatt are going to be the practical units of electrical energy, which we use in our residential areas and industry. All the electric bills are having the units of kilowatt hour. And obviously, now what is kilowatt? That is going to be the power, and hour is the unit of time. So power and time. So power is kilowatt and time is 1 hour. So kilowatt hour is going to be the electrical energy units. So now what next? What next is very simple for you. Now heating effects of current. Now what heating effects of current is? Very simple thing. The next topic is heating effects of current. Now, what are the heating effects of current? If you think about old bulbs which are having filaments, if we pass electrical energy through that, you all know that filament becomes hot. So we are just taking into account that kind of thing. If that is going to be our filament, let's say that is going to be our filament, and if the current passes through that. Now why this filament is having so many curls? Because if we increase the number of curls, we can increase the number of collisions as well. Now if there are number of collisions, if we increase the heat, the number of collisions going to increase. If we give extra energy to wire, the number of collisions going to rise, and this give rise to the resistance as well. And vice versa. If resistance is going to rise, the collisions are going to rise, and there is going to be a heating effect. That's how it works. If we are going to increase the resistance of any coil by giving curly shape to the wires, so always they are going to be, number of collisions are always going to be rise, because the free electrons going to collide with the ions and atoms of a conductor. So which means there's always going to be a heating effect. That's how it works. Resistance is going to be higher, the number of collisions going to be higher, and then there's a rise in the temperature or heat, you can say. So it's going to be very simple for you. Now, by the same concept, we have a formula which is known as Joule's law of heating. Now, what is Joule's law of heating? It's very simple for you. Again, we are going to use the same technique here. Now, what is power? Power is going to be potential difference into current, which we have already done in the previous topic. So, the power can be written as work upon time. So, that is going to be VI. Now, this work is V into I into T. Now, this work is converted into heat energy. Now, what is heat energy? We can take as a H. So which means V I into T. Now using Ohm's law, Now what is Ohm's law? V is equal to IR. So we are just putting that value here. So it means IR into I into T. So H is going to be I square RT, and which is known as Joule's law of heating. It's very simple for you. So Joule's law of heating is H is equal to I square RT, which means the heat energy is proportional to current square, heat energy is proportional to resistance, and heat energy is proportional to the time interval. So the heat produced by any conductor is proportional to the square of current passing through that conductor, the resistance of the conductor, and the time interval for which the current is passing through that conductor. That all included in the Joule's law of heating. And if you want to have a diagram of that, you can easily have a diagram of that. So which means that is a positive negative battery. V is here. So let's say that current is here, and that is going to be the resistance. So that easily you can have a diagram of Joule's law of heating as well if AB can be taken as a conductor, which is having a resistance R, and if current I is flowing through that conductor and the potential difference applied is V, and for the current is going through that conductor for a time interval of T, then you can easily conclude that H is equal to I square RT. So that is going to be the Joule's law of heating. So that is all about today's topic. Hope you enjoyed that, and do safe and be safe, be happy, and always do numericals of physics which are going good for you. Thank you so much. Thank you.